Good morning, everyone. Yes, what we have seen in the last lecture. Okay, before going to that one, I hope you have attended yesterday's your convocation ceremony. Congratulations of all of you for getting a degree, BSc degree. Right? Actually, in physical one, it was very nice experience. No, you come to the university from your colleges and then you receive the degree with wearing the gown and all. Right? It is not possible nowadays. Okay. Attend केलात का?
Yes, ma'am.
Okay. Who is a gold medalist from you people? Whether it is from maths student? BSc मध्ये कुणाला भेटला गोल्ड मेडल? Yes, anyone from your college? तुमच्या कॉलेजमधून आहेत का? BSc गोल्ड मेडलिस्ट माहिती आहे का नाही BSc गोल्ड मेडलिस्ट कोण आहेत? This is what a drawback, no? When you come for the physical convocation, you know who is a gold medalist. Some peoples from the media will come and take photos, and you just wear that gown and come to university for receiving your degree and all. Th- That is what the meaning of convocation. Yes, no one knows about who is a gold medalist in BSc. पता है क्या गोल्ड मेडलिस्ट क्या होता है? हेलो, am I audible to everyone?
Yes, ma'am.
Yes, ma'am.
माहिती आहे का नाही मग? हो तरी म्हणा, नाही तरी म्हणा, नाही माहित नाही आम्हाला कोण आहे गोल्ड मेडल, काय असते गोल्ड मेडल. ओके,
नाही माहिती मॅम.
हा. कोण आहेत गोल्ड मेडल? गोल्ड मेडलिस्ट कोण आहे तुमच्यामधून BSc? Maybe from not mathematics, if she is from other subject, you may know, no, if it is from your college itself.
कोणत्या कॉलेजला मिळाले मॅम?
तेच विचारते ना मी. Okay. It means that you haven't attended yesterday's convocation ceremony. At least you can see the list available on the university website ना. Website पे available होता है list. BSc में किसको गोल्ड मेडल मिला, किस कॉलेज से, किस नाम से गोल्ड मेडल मिलता है. Actually, the concept of a gold medal is that हमारे यहाँ पे भी मैथ्स में MSc मैथ्स के लिए गोल्ड मेडल पहले नहीं था. It starts from the नेवाड़ी and then it comes to me. क्या होता है वहाँ पे? अगर कोई हाईएस्ट डिग्री वाला होता है तो उसको सिर्फ सर्टिफिकेट मिलता है. अगर कोई मैथ्स MSc मैथ्स के लिए गोल्ड मेडल दे दो हमारी तरफ से, ऐसे कोई पैसे डिपॉजिट करता है 1 लाख और व्हाट इज द अमाउंट आई डोंट नो एग्जैक्टली. Near about 1 lakh is the amount which should be deposited in university account, and due interest whatever generated from that, with the help of that only gold medal is prepared. Okay, whenever you might have, कुछ लोगों ने आपने अटेंड किया होगा कन्वोकेशन ऑनलाइन जो था, वहाँ पे जब भी स्टूडेंट्स का नाम बोलते हैं और उसके पहले वो लोग बताते हैं कि ये गोल्ड मेडल किसने स्पॉन्सर किया. ओके, वो 1 लाख आपको लाइफ टाइम के लिए ही यूनिवर्सिटी के पास रखना पड़ता है. एंड देन वट एवर द इंटरेस्ट जनरेटेड एवरी ईयर, with the help of that only the gold medal is prepared. माहिती होता का हे?
No, ma'am.
बघा बघा कन्वोकेशन सेरेमनी कालची जी लिंक आहे ना, ओपन करून बघा कोण आहेत गोल्ड मेडल, किंवा वेबसाईटवर जावा युनिव्हर्सिटीच्या, काय असते ते बघा. It doesn't mean कि आपको गोल्ड मेडल ही लेना चाहिए. Just I am saying that it is a nice idea. एक फीलिंग जो होता है ना कि वी गॉट अ सर्टिफिकेट, जब तक वो डिग्री वाला फीलिंग नहीं आता है तब तक आपके पास वो गाउन वगैरह पहन के जब फोटो निकालते हो कन्वोकेशन की, दैट इज व्हाट अ गुड फीलिंग. ओके, लेट मी शेयर यू माई. हमारे टाइम पे वैसा वाला नहीं था. गोल्ड मेडल का जो गाउन होता है ना थोड़ा डिफरेंट था. अभी तो वाइट किया है. कैन यू सी दिस?
यस मैम. यस मैम.
ओके, ये वाले पहले गाउन थे, अभी वाइट किया है. कि ऐसा वाला गाउन सभी को मिलता है और आपका ना अपना डिग्री आप ले सकते हो. फोटो दिसला का तुम्हाला?
यस मैम.
Yes, ma'am.
ड्यू टू कोविड यू हैव मिस्ड आउट फ्रॉम दैट. Okay, so in the last lecture we have seen the relation between capital delta and the small delta, and in the last lecture I have told you that in we are going to see the principle of the least action. Okay, so we are going to see now the principle of the least action. Okay, I hope you remember the definition which we have seen about the action. Okay, what is the definition for action? Line integral of the twice of the kinetic energy is called a action. Now we have to prove principle of a least action. The question may be state and prove. State and prove principle of the least action. Is the screen and my voice is audible to you?
Yes ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
What is the statement? First, we'll write down that the path of a conservative sclerodermic system is such that okay, the path of a conservative sclerodermic system. Conservative means what? The force is constant. Sclerodermic means what? The constraint does not involve the time t. The integral of the kinetic energy along it has a extremum value. The integral of kinetic energy along it has extremum value. Or or statement for this I can write down. Read the statement carefully so that you can understand. For the conservative sclerodermic system, in which H is conserved, if you remember in the last lecture, somewhere I have told you this physical significance of Hamiltonian, in which we have studied for the conservative sclerodermic system, H is constant as well as H is a total energy. For the rheonomic system, it may be constant of motion, but it is not a total energy. आठवते का physical significance? At that time, I told you that the same question will be there in the set exam of the paper somewhere in the 2015. आठवते का सगळ्यांना physical significance of Hamiltons, in which we have seen the two part. Okay, first sclerodermic system. For what will happen for the sclerodermic system? H is constant as well as H is a total energy. And for the rheonomic system, H may be constant of motion, but it is not a total energy. If you remember, we have proved it is equal to H is equal to constant and H is equal to T plus V. And for the second one, for the sclerodermic, we got it is some T2 plus T1 minus T minus V. ऐसा कुछ तो मिलता है. So it is not a total energy, but it may be a constant of motion. So here, in case of conservative sclerodermic system in which H is constant or H is conserved, the principle of its least action states that the principle of least action states that delta variation in action is zero. Delta variation in action is zero. Okay, that is what we have. Delta variation in the action equal to zero, which means that delta variation in the action मतलब क्या होगा? Integration t naught to t1 to t dt equal to zero. Okay. So this is what the given with the statement क्या होता है आपके पास conservative sclerodermic system है, and then we want to prove that the integral of kinetic energy along it has a extremum value. What do you mean by extremum value?
Minimum path.
In this case, it may be minimum, but the actual meaning of extremum is either minimum or maximum, such that the delta variation in the action is zero. There are the two statements. Line integral of kinetic energy भी वही होगा आपका, and here meaning of delta variation is also same. Okay, delta variation equal to zero मतलब क्या होता है? इंटीग्रल ऑफ काइनेटिक एनर्जी मतलब क्या है यहाँ पे? इंटीग्रल ऑफ योर काइनेटिक एनर्जी, उसका आपका डेल्टा वेरिएशन फाइंड आउट करना पड़ेगा. दैट इज कैपिटल डेल्टा वेरिएशन शुड बी इक्वल टू जीरो, देन ओनली यू कैन फाइंड आउट एक्सट्रीमम. नो, डेल्टा वेरिएशन या डेरिवेटिव जब आप फाइंड आउट करोगे, फर्स्ट डेरिवेटिव इक्वल टू जीरो, देन ओनली यू कैन गेट द एक्सट्रीमम वैल्यू. ओके, सो मीनिंग ऑफ एक्सट्रीमम वैल्यू इज इक्वल टू डेल्टा वेरिएशन इन एक्शन इक्वल टू जीरो. इक्वल टू जीरो अगर आप फर्स्ट डेरिवेटिव करते हो तभी आपको एक्सट्रीमम मिलेगा. बरोबर? आर यू गेटिंग मी?
Yes, ma'am.
Yes.
Okay. Now, if you want to prove delta this term, क्योंकि आपको क्या प्रूव करना है? लाइन इंटीग्रल ऑफ काइनेटिक एनर्जी इज इक्वल टू जीरो, और लाइन इंटीग्रल ऑफ काइनेटिक एनर्जी हैज अ एक्सट्रीमम वैल्यू. ओके, लाइन इंटीग्रल ऑफ काइनेटिक एनर्जी हैज अ एक्सट्रीमम वैल्यू. अगर आपको ये प्रूव करना है, इसका मीनिंग क्या है? आपको डेल्टा वेरिएशन इन द line integral of 2 times the kinetic energy is equal to 0. Okay, if you are having any doubt you can ask me. एक्सट्रीमम का मीनिंग ये होता है कि आपको फर्स्ट डेरिवेटिव इक्वल टू जीरो करना है. फर्स्ट डेरिवेटिव की जगह पे हम लोग यहाँ पे क्या फाइंड आउट कर रहे हैं? डेल्टा वेरिएशन. ओके, So let us start with the proof. If I want to prove that this whole term equal to 0, so first we will write down what is the value of a 2t. Okay, what is the value of a 2t we have? It is summation over j qj dot dou t by dou qj dot, which is from our unit 1. If you remember, for in the first unit, in the last theorems of the first unit, we have seen this, that kinetic energy can be written as a quadratic with the help of quadratic formula, right? If you remember, we have written this as a T2 plus T1 plus T naught, and then finally we have written for the sclerodermic and rheonomic system. Okay, अगर नहीं याद है तो आप यूनिट 1 के लेक्चर्स फिर से देख सकते हो जहाँ पे मैंने ये आपको सिखाया है. ओके, now we want to find out the value of this term. So to find out the value of this term, let us go with the Lagrangian dou L by dou Qj dot का value क्या है? Pj, right? But what is L? L is nothing but T minus V, right? So we get this is Pj is equals to dou T by dou Qj dot minus dou V by dou Qj dot. Now what is the value of a dou V by dou Qj dot, which is nothing but equal to 0. Why this is 0? But because we know that in the conservative sclerodermic system, potential energy is not a function of the generalized velocity. Okay, so we know that the potential energy is not a function of generalized velocity. Hence, Pj is equals to dou T by dou Qj dot. So this is what we got. Okay, ये सब भी हमने already देखा है unit 1 में, right? So that's why I'm not explaining in detail. So just put them in the above formula. So we get it is 2t is equals to summation over j qj dot dou t by dou qj dot की जगह पे आप क्या लिख सकते हो डायरेक्टली? यू कैन राइट डाउन दिस एज अ pj, राइट? pj का वैल्यू हमें क्या मिल गया यहाँ पे? dou t by dou qj dot. ओके, now we want to prove that. What is our aim to prove that? Delta variation in action equal to 0. So consider LHS and prove the RHS, right? So in this case, what we'll do, we will consider the LHS and we will prove the RHS, right? So what we should consider now, delta variation in the T naught to T1 to T equal to 0. ये prove करना है तो we will consider this one. And what is the value of a 2t? We have got integration T naught to T1. We got the value of 2t summation over j pj qj dot and integration with respect to t, right? इस सभी वैल्यू को हमें प्रूव क्या करना है? इक्वल टू 0. समझते सगळ्यांना?
Yes, ma'am.
Okay. So instead of saying consider, you can say that to prove that. That is to prove that you have to prove it is equal to 0. Okay. So now let us start with the proof. क्योंकि हमें यहाँ पे डेल्टा वेरिएशन कंसिडर करना है. कैपिटल डेल्टा वेरिएशन का मीनिंग क्या है? If you remember in the last lectures, I have told you what is a capital delta variation. Right? This is time. Time is allowed to vary in the capital delta variation, but generalized coordinate that is q1 q2 is a fixed out. This is what your qj, ये आपका qj है, ये time variable है, right? And this is what your path a p b, right? This is what your path, or you can say abc is a path, and this is what t naught is initial, and this is what t1, right? And then we can have here another path which is a path followed. ये क्या है आपका? Actual path है ये जो हम draw करने वाले. This is what a ideal path, right? So you can have this is what P, Q, and R. So here you can have this is suppose I can write down this is as here T naught plus delta T naught, that is T naught में मैंने कुछ extra value add किया है, that is time is allowed to vary in this case. Okay. Small delta variation में क्या condition है? Time is not allowed to vary, but here small delta T naught and small delta T1 ensures that their time is allowed to vary. T naught to T1 है, fix नहीं है. Okay, you can vary the time, right? But q1 q2 are fixed out. Okay, endpoints are fixed out, but the time is allowed to vary. Whether you understood the figure, try to draw by
Yes, ma'am.
your hand itself so that you can understand what I am trying. क्योंकि अगर मैं कुछ ड्रॉ करूंगी आपको कुछ समझ में नहीं आएगा. सो आप खुद ये फिगर ड्रॉ करके देखिए, राइट. टी नॉट में कुछ एक्स्ट्रा टाइम ऐड करके हमने एक नया पाथ जो बनाया है वो आपका एक्चुअल पाथ है, राइट. So what is our objective? We have been provided that conservative sclerodermic system, okay, in which H is constant. Now consider A, B, C is a actual path given and P, Q, R is a valid path, okay. Valid path and actual path. If delta variation at the end points of the path are not terminated at the same end point, the points A and C of the actual path after the delta t takes the position P and are such that the coordinates of the endpoints are fixed. मतलब Q1 Q2 ये आपके fix है, that is AC and PR, these are fixed out, but the time is allowed to vary. Okay, whether you understood the construction, simply मैंने यहाँ पे construction आपको read करके दिखाया है, right. ABC is the actual path and PQR is a valid path and capital delta variation में क्या होता है, time is allowed to vary but the endpoints are fixed out. Okay. So now let us start the proof. Consider, क्योंकि हमें क्या प्रूव करना है, यहाँ पे हमने क्या लिखा है, to prove that delta variation integration t naught to t1 summation over j pj qj dot dt equal to 0. Okay, so now let me write down delta variation t naught to t1 summation over j pj qj dot dt equal to 0. Now we know that from the Hamilton's principle we have H is equal to, what is H? Summation over J Pj Qj dot minus L. So from this I can have the value of this summation over J Pj Qj, correct? Summation over J Pj Qj dot will be equal to H plus L from this, क्योंकि हमने ये पहले डिफाइन किया ना हैमिल्टन्स. येत आहे ना सगळ्यांना हैमिल्टन्स, हैमिल्टन, रुदियन,
Yes,
लॅग्रॅन्जन,
sir.
माहिती आहे ना सगळ्यांचा डिफरन्स. Okay, assuming that you know, so what is H? We have constructed Hamiltons, we have constructed with the help of Lagrangian. So you can see here again L is a function of Qj dot and T. What is H? H is a function of Pj, Qj and T. What is R? R is a function of Pj, Qj and Qj dot. ओके, सो ये पीजे क्यूजे डॉट जो समेशन वाला टर्म है उससे हमने ये फाइंड आउट किया. नाउ लेट अस पुट अप बैक इन द अबव इक्वेशन. ये इक्वल टू 0 हमें प्रूव करना है, राइट. सो नाउ लेट अस पुट अप बैक इन द इक्वेशन. हमने वही कंसिडर किया था ना. सो I can write down integration t naught to t1. Now it is 2t dt will be equal to the delta variation integration t naught to t1. The value of this I can write h plus L dt, right, which is equal to I can have delta variation in the t naught to t1 h dt plus delta variation in the t naught to t1 L dt, right. ये हमें प्रूव करना है, right. Now we know that H is constant, right. As it is a conservative sclerodermic system, we can say that H is conserved or H is a constant. So what is the integration of the first term? अगर H constant है तो integration क्या हो जाएगा?
T.
Right. So integration will be as it is. So I can have this delta as it is, right. So H can be taken outside and this we can write down simply if I have written H is outside. So you can write down this as T only within the limits T naught to T1 plus we have to find out the value of a delta, capital delta variation in T naught in LDT. Okay, small delta variation तो हमें पता है ना. Small delta variation T naught to T1 L is equal to 0. ये तो हमें पता है, right. We want to find out capital delta variation in L. Okay. सो इफ आई वांट टू प्रूव दिस होल टर्म इक्वल टू जीरो, क्योंकि हमें क्या प्रूव करना है, इंटीग्रेशन टी नॉट टू टी वन डेल्टा वेरिएशन इन टू टी डी टी इक्वल टू जीरो, ये पूरा टर्म हमें इक्वल टू जीरो प्रूव करना है। ये तो कांस्टेंट है, ओके। सो दिस इज फिक्स्ड आउट एच डी टी विद इन द टी नॉट टू टी वन. Now if I want to prove this whole term equal to zero, I have to prove that this is minus of h delta t t naught to t1, बरोबर. झिरोच प्रूव्ह करायचं आहे ना, हे तर फिक्स्ड आहे, म्हणजे ह्याला काय प्रूव्ह करावं लागेल, एक्झॅक्टली इक्वल आहे ना अपोजिट. येस और नो. 2 minus 2
Yes,
equal
ma'am.
to 0 येणार ना. हे टर्म तर फिक्स झाली तुमची, h इज कॉन्स्टंट, सो विच मीन्स दॅट h डेल्टा t within the limit t naught to t1 is some fixed number. If I want to prove this whole term equal to 0, so which means that I have to prove that delta variation in L dt equal to minus of the same quantity. Okay, so for that let me name it as some equation 1 and we will solve our second term. Okay, that is, consider, you can write down, consider integration t naught to t1 L dt. Okay, we want to prove it is. So for that we know the relation between capital delta and small delta, which we have found in the next last lecture. Capital delta is equal to d delta plus d by dt of capital delta t. ये डेल्टा का मैंने सिर्फ वैल्यू सब्स्टिट्यूट किया है, दिस एज इट इज इंटीग्रेशन टी नॉट टू टी वन एल डी टी, राइट. So now on the next step, what you can do, delta variation in t naught to t1 L dt plus d by dt of delta t, right? Integration t naught to t1 L dt, right? But we know that small delta variation in capital L, that is Lagrangian, is equal to 0. Why this is so?
Time not vary.
Okay, let us go one by one. We'll prove this. Okay, क्या करेंगे हम लोग, ये स्मॉल डेल्टा एज इट इज है, यहाँ पे कैपिटल डेल्टा टी है, राइट. सो व्हाट वी विल डू, वी विल गो वन बाय वन. सो स्मॉल डेल्टा वेरिएशन टी नॉट टू टी वन एल डी टी प्लस हैमिल्टन्स प्रिंसिपल है ना, ये आपका हैमिल्टन्स प्रिंसिपल, राइट. So capital delta T will be outside d by dt integration T naught to T1 L dt. Now you can see integration and derivative with the same term, that is T. So what will be the result? हाँ सांगा, डेल्टा टी हे असंच राहणार आहे, इंटिग्रेशन अँड डेरिव्हेटिव्ह विथ रिस्पेक्ट टू सेम टर्म काय येणार आहे,
LDT. Only L.
right. So it is simply L I can write down, within the limit again you can write T naught to T1, right. Now yeah, if I, ये भी अभी आपका फिक्स्ड हो गया है, राइट. दिस वन इज ऑल्सो फिक्स्ड आउट. हम क्या करना है, हमें क्या प्रूव करना है, योर इक्वेशन वन को इक्वल टू जीरो प्रूव करना है. ये वाला आपका पूरा टर्म है ना, ये इक्वल टू जीरो प्रूव करना है. इसमें से फर्स्ट तो फिक्स्ड आउट हो गया, सेकेंड टर्म हम लोग सॉल्व कर रहे हैं, राइट. सो वी आर सॉल्विंग अवर सेकेंड टर्म. So if I want to prove this is minus of this one, so first we have to evaluate small delta variation, that is first term. Okay, so for evaluating our first term, ये वाला तो fixed हो गया, right. Let me give the numbering for the second equation. Now again we will consider the first part. Okay, considering delta variation in t naught to t1 L dt is equal to, now for considering that L is nothing but a function of qj dot and t, बराबर. So now we want to solve this. How to solve this one, this integration as it is, integration t naught to t1, and again you can have summation over j derivative of L with respect to qj, right, and then delta qj plus next is summation over j L with respect to qj dot delta qj dot plus next is again L with respect to t and delta t, right? ये फिक्स हो गया. ओके. नाउ we know that there is no variation in the time, so you can have delta t is equal to 0. Okay, delta t within the limit t naught to t1 is equal to 0. Now we know that what is the value of dou L by dou Qj dot, and with the help of that we will go one by one, right? What is the value of a dou L by dou Qj? It is a Pj dot. Dou L by dou Qj is a Pj dot. What is the value of dou L by dou Qj dot? That is Pj. ये दोनों वैल्यू हमें पता है. फ्रॉम द फर्स्ट यूनिट वी हैव डन दिस इन डिटेल. देखा है ना हमने. डेल्टा वेरिएशन इन द टी नॉट टू t1. We'll keep this L dt as it is. Right, now we will write down it is integration t naught to t1. Now value of this you can write down this summation over j. This is what pj dot. इसका वैल्यू pj dot होगा delta qj plus next is summation over j pj as it is this delta qj dot, right? And then integration is dt. With respect to t we are finding the integration ना, ये वाला dt. Okay, ये तो zero हो जाएगा because there is no variation in the time. You can write down the reason for this step is delta t within the limit t naught to t1 is equal to 0. Since small delta variation, in the small delta variation there is no allowedness for the time to vary. Allowed नहीं किया है. Okay, time is not allowed to vary in small delta variation. So here we have completed up to this one. अभी क्या करना है आपको? This is nothing but just like your u into v rule, if you see carefully. So let me write down, then you can understand summation over j d by dt of pj delta qj dt. ओके, डेरिवेटिव ऑफ दिस. अब इसका डेरिवेटिव, ये जो ब्रैकेट है ना, ये बॉक्स जो मैंने बनाया, इफ यू आर गोइंग टू सॉल्व दिस, व्हाट इज डेरिवेटिव pj डॉट एज इट इज डेल्टा qj, and then sorry, pj dot derivative first term delta qj as it is plus, right, pj as it is, then derivative of a delta qj, that is delta qj dot. is idea clear? जो मैंने ब्रैकेट में बॉक्स में लिखा है वो आपका डेरिवेटिव, राइट? उसका अगर आप डेरिवेटिव सॉल्व करोगे तो आपको पहले वाला टर्म मिल जाएगा. ओके, दिस टर्म यू आर गोइंग टू गेट. यस, एवरीवन गेटिंग मी?
Yes, ma'am.
ओके, सो सिंपली हमने डेरिवेटिव एडजस्ट किया u इंटू वी रूल के हिसाब से. आपका क्या आएगा, जो डेरिवेटिव आप फाइंड आउट करेंगे आपका पहले वाला टर्म मिल जाएगा. ओके, सो व्हेनेवर यू गोइंग टू गेट अ अर्लियर टर्म, सो क्या करेंगे हम लोग यहाँ पे? Now this is what delta, the value of delta, again we are going to use small delta, is nothing but we are going the relation small delta is nothing but capital delta minus d by dt of a capital delta t. Now we are going to use this relation. This is integration t naught to t1. d by dt will be as it is, this summation over j as it is, summation over j pj, and then capital delta minus d by dt of a delta t, and the outside of this qj. Okay, ये simply small delta का value हमने put up किया. Okay, and integration is again with respect to t as it is. Okay, so let us evaluate one by one. क्या करेंगे हम लोग यहाँ पे? Here you can see this is what delta qj, no, sorry, here it should be qj dot, गलती से आ गया है वहाँ पे. Okay, so this is what integration t naught to t1 d by dt of. Now let us evaluate this bracket. This you will get summation over pj, और ये डेल्टा आप अगर आउटसाइड में ले लोगे तो यहाँ पे क्या आ जाएगा, डेल्टा qj minus again this summation over j as it is pj d by dt of capital delta t, and this is what qj we will write down, delta t will outside and derivative of a qj ये वाला आपका inside multiply हो जाएगा, right? This delta t as it is, and again integration is with respect to t. Okay, You have to solve it very carefully so that you can understand. Now you can see integration and derivative with respect to same term. ये वाला integration है आपका और ये वाला derivative with respect to same variable. So can I write down directly this as summation over j pj delta qj minus summation over j pj dqj by dt? I can write down this is simply as a qj dot, बरोबर, and delta t within the limit t naught to t1. Okay, yes, everyone understood this step?
Yes, ma'am.
Okay, now you can see this delta qj is equal to 0. Why this is so? Because we have seen in the figure itself that is time is allowed to vary but the end points are fixed out. q1 q2 को हमने change नहीं किया. q ऐसा लिखा है कि हमने यहाँ पे q1 plus delta q1, no. So the time is allowed to vary but the coordinates are not, generalized coordinates are fixed out. So you can say that delta qj is equal to 0. Why this is 0? Because in the capital delta only time is allowed to vary but the generalized coordinates are fixed out. So if generalized coordinates are fixed out and time is allowed to vary, so you can say directly that the first term is equal to 0. So above equation becomes, what equation becomes? This equation will be now equal to, it is minus summation over j pj qj dot delta t within the limit t naught to t1, correct? So ये वाला आपका equation मिल गया. Okay, now with this equation 3 where I am going to use, I am going to use this in our equation 2. Okay, इसका वैल्यू हमने फाइंड आउट किया, इसका वैल्यू हमें क्या मिला है, इक्वेशन नंबर 3. समजताय सगळ्यांना आता?
Yes, ma'am.
Okay, so just we have got the value of equation 2 में का जो आपका first term था, so equation 2 और equation 3, right? So equation, using equation 3, equation 2 becomes, what it becomes? So equation 2 क्या था आपका? Okay, let me show you how it looks like. Equation 2 is nothing but your capital delta you are going to consider. Capital delta t is equals to, ओके, इट वाज अवर कैपिटल डेल्टा एंड यहाँ पे आपका स्मॉल डेल्टा का वैल्यू आपको क्या मिल गया यहाँ पे, माइनस समेशन ओवर जे पी जे क्यू जे डॉट डेल्टा टी विद इन द लिमिट टी नॉट टू टी वन, which is capital delta t naught to t1 L dt, right? And here L delta t naught to t1. ओके, नाउ अभी क्या करेंगे हम लोग, इफ आई टेक अ माइनस साइन आउटसाइड बिकॉज बोथ आर विद इन द सेम लिमिट, सो इफ आई टेक अ माइनस साइन आउटसाइड I can have, this is what summation over j pj qj dot minus l, minus minus become plus and this is again within the limit t naught to t1 और ये जो आपका डेल्टा t है वो आप यहीं पे रखो. ओके, so this is what your capital delta variation in t naught to t1 l dt, right? Now what is the value of this term? क्या है ये आपका पूरा, इफ यू रिमेम्बर फ्रॉम द हैमिल्टन्स, हैमिल्टन्स कैसे आपने डिफाइन किया है? ओके, यहाँ पे है. ओके, एच इज नथिंग बट समेशन ओवर जे पी जे क्यू जे डॉट माइनस एल, और हमें क्या मिल गया, वही टर्म मिला है ना, समेशन ओवर जे पी जे क्यू जे डॉट माइनस एल इज नथिंग बट योर एच, बरोबर आहे? एच 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 ची व्हॅल्यू काय, हैमिल्टन्स, Hamilton's formulation. So with the help of Hamilton's formulation, you can say that the value of this whole term is nothing but summation over j pj qj dot is nothing but h. You can write down again the reason. H is nothing but summation over j pj qj dot minus l, and hence you get capital delta variation in t naught to t1 L dt is equals to minus the value of this is h dt within the limit t naught to t1. Okay, अभी ये आपको क्या करना है, this is what say equation 4 now I have to use in our equation 1. Okay, what was our equation 1? यहाँ पे आपने अगर remember है तो आप सोच सकते हो यहाँ पे एच डी टी था और हमें क्या प्रूव करना था, दिस इज नथिंग बट मायनस ऑफ एच डी टी. ओके, आठवतंय का सगळ्यांना? इक्वेशन 1 आपल्याला प्रूव्ह करायचं होतं इक्वल टू 0, बरोबर?
हो मॅम.
Okay, so capital delta T naught to T1 LDT. Okay, second term of our equation 1 we have solved now. Okay, now you can say using equation number 4, in our equation 1 what we get, integration T naught to T1, integration T naught to T1, and what is that? This is what with the capital delta 2T dt is equal to, this is what h डेल्टा टी विद इन द लिमिट टी नॉट टू टी वन. और इसका वैल्यू आपको क्या मिल गया सेकेंड टर्म का, दिस होल टर्म, इसका ही हमने वैल्यू फाइंड आउट किया था ना इक्वेशन 1 का सेकेंड टर्म, which we got it is minus of h delta t within the limit t naught to t1. So now you got it is equal to 0. So delta variation in the action we have proved it is equal to 0, which is nothing but the principle of the least action. Okay, so in this way we have completed up to this one. Okay, now last question of our this unit is remaining, that I will tell you to do as a homework, Jacobi's form of principle of a least action. Okay, try to do this in at home. Otherwise we'll see in the next lecture. Yes, anyone having any doubt you can ask. क्या करना था आपको, डेल्टा वेरिएशन इन एक्शन इक्वल टू 0 प्रूव करना था, उसके लिए हमने समेशन पी जे क्यू जे डॉट फाइंड आउट किया, राइट, एंड देन वी हैव पुट अप द वैल्यू ऑफ एच, एच का वैल्यू पुट अप करके एच प्लस एल प्रूव किया, राइट, एंड नाउ इक्वेशन 1 वी हैव टू प्रूव इक्वल टू 0. फॉर दैट वी आर सॉल्विंग अवर second term of equation 1, we have got equation number 2. इक्वेशन नंबर 2 में भी हमें ये वाला आपको सॉल्व करना है. ओके, आफ्टर सॉल्विंग द फर्स्ट टर्म ऑफ इक्वेशन 2 यू हैव टू नाउ गेट अ इक्वेशन नंबर 3. यहाँ पे सिंपली कैलकुलेशंस है, थोड़ा सा आपको सभी रिजल्ट्स फाइंड आउट करने पड़ेंगे. इफ यू रिमेंबर ऑल द रिजल्ट यूजिंग द रिलेशन बिटवीन स्मॉल डेल्टा एंड कैपिटल डेल्टा, you get the result, and just use those equation and you get the result. Okay, if you're having any doubt you can ask. Go through the result once again, try to write down. आप जब तक लिखोगे नहीं तब तक आपको कुछ नहीं समझ में आएगा, अदरवाइज यू विल फील दैट हे मॅडम काय करतायत, इक्वेशन 1 लिहितायत, इक्वेशन 1 मधून 2, 2 मधून 3, 3 चा बॅक पर सबस्टिट्यूशन, you will not understand anything. Okay, you should go through this once again by writing your with your hand only, so that you can understand. Okay, thank you. You can leave the meeting, you can join the next lecture. In the next lecture we'll go for the last point of this chapter, and then we'll start with our fourth unit. Okay.